Hello students, I'm making this video on section 4.4, the least common multiple, today to help you remember what we did in class. Also, for so many students that are out sick, I think this might be the best way for you to get the information from me and also to be able to fill out your notes. So in this section, I am going to introduce the least common multiple, but I'm also reviewing what we did in 4.2, which was the greatest common factor. So for those of you that missed the 4.2 notes, this will also be a lesson to help you understand what we did prior to 4.4. So these definitions are in your textbook: the multiple of a whole number, the common multiple, and the least common multiple. And I'm going to actually let you just get those out of the textbook. I think maybe you know you've had multiples of numbers before. The first multiple of a number starts with the number himself. So an example would be, if I want you to list the first three multiples of the number 4, I'd say, okay, the first one is 4 times 1. That's 4. The second multiple of 4 is 4 times 2. 8. Third multiple would be 12, and on and on and on. There is no greatest common multiple between two or more monomials because our numbers are infinite. We can just keep going and going and going. Okay, so common multiples, in order to have something in common, you have to have two or more. Like if you have something in common with somebody, you have to have two or more people. It's the same way with monomials. To have common multiples, you have to have two or more monomials. So we are going to do some examples of least common multiples. And I just want to say quickly, you have done this in 5th and 6th grade, but we're going to use a method that's different from 5th and 6th grade, and it's also different from anything in our textbook. So it will be very important as you do your homework that you use these notes or have this video up so that you know the format that we actually are going to be doing it in our class. So some kids say, well, can't I please do it the way I did it before? And my answer is no, you can't. Because when you get into Algebra 1, soon you will not be doing the list with the circling and everything that you did in 5th or 6th grade in elementary school. This is the method you will use. So to find the GCF and the LCM of two or more numbers or monomials, when you have variables with them, you start with the prime factorization. The very first thing you do is get the prime factorization of 16 and the prime factorization of 24. And here's what it looks like. Prime factorization of 16. I'm trying to get rid of this thing. I might choose to start with 8 times 2. Maybe you started with 4 times 4. That's fine. You can use a little factor tree and put little trees in there like if you like that format, but I usually just list right underneath each other. Now I ask myself, is 8 a prime number? Am I finished? Nope. 8's 4 times 2. And I have to bring this 2 down. Is 4 a prime number? No, I'm still not finished. 4 is 2 times 2. And here's this 2, and there's the other 2. At this point, I have all prime numbers, and I'm ready to do my check. The check is a very important step. If you can do it in your head, that's great. 2 times 2 is 4, times 2 is 8, 8 doubled is 16. I am now back where I started, and I can put a little check mark there. I will be looking for the check marks on your prime factorizations. The last step in writing a prime factorization is to put it in exponential form and draw a box around it. I'll explain why we do that later. Now I've got to go do the prime factorization for 24. Maybe I'll do him in another color so it's a little easier for you to see. 24, maybe I'll start with 8 times 3. 8's not prime. 4 times 2, bring down the 3. Who is prime? 4. 2 times 2, I'm bringing down this 2 right here and this 3 right here. So with any luck, when I do my check, When I multiply all of these factors back, I really do end up with 24. 3 times 2 is 6, doubled is 12, doubled is 24. Yep, it worked. Last step, write it in a box and put it in exponent form. And now since I have two bases, I have a 2 and a 3, I'm going to write the smallest base first, the next bigger base second. And I'm going to put a dot in between them to show that it's a multiplication process. So I've completed the first step of my GCF and LCM, prime factorizations. The next thing you do is make a T-chart. It looks like this. On one side, we're going to do the greatest common factor. On the other side, we're going to do the LCM. Let's talk about the GCF. We did the GCF in section 4.2, but as a review, the GCF, you go back and you look at your boxes and you ask yourself, what bases do I have in common? What do I see in both boxes? And you write that base down. I see a 2 over here and I see a 2 over here. I write it down, and I just write it down one time. I see a 3 over here, but there's no 3 in this box, so I'm not going to write him down. I'm finished with writing my bases. The second step is the exponent. What exponent do I put on the 2? Well, I am looking for the smallest exponent that I see in my two boxes. Here I see 2 to the 4th, and here I see 2 to the 3rd. 3 is smaller than 4, so 2 to the 3rd is going to be what I write down. I don't have any more multiplication. I am going to just multiply 2 to the 3rd power out. 2 times 2 times 2 is 8, and 8 is my GCF. So again, let me review for the GCF. You start with the prime factorization. You box it up. You make sure that your factors multiply back to your original number and that they're all prime. We did that. We ended up with 2 to the 4th power for 16 and 2 to the 3rd power times 3 for 24. To find your GCF, you look in your boxes and you write down only the bases that occur in both boxes, the 2. Last step, put on the exponent. Look at your exponents. This 2 is to the 4th. This 2 is to the 3rd. I take the smallest number. That would be the 3. And then I ask myself, okay, well, what is 2 cubed? It's 8. That's my GCF. All right, let's move on to the LCM. The LCM is different. This is what's in 4.4. The LCM, you go back to the prime factorizations. And now, instead of having to have them in common, you write down every single base you see. I see a 2. I see a 2 over here. I'm not going to write him down again. I'm only writing him down once. And then I also see a 3. Now, in order to put the exponents on, you go back, and instead of picking the lowest exponent, like we did in the GCF, what do you think I'm going to do? I'm going to take the highest exponent I see for each base. So here's a 2 to the 4th. Here's a 2 to the 3rd. I'm going to put a 4 on it. Here's a 3 to the 1st. There's no 3 over here, so I'm going to use the 3 to the 1st. You don't have to write this one as an exponent, but if it helps you remember what the power is on that 3, it's easy to write it down. Now I'm finished, and I need to multiply these two guys together. 2 to the 4th power. 2 times 2 is 8, times 2 is 16. No, 2 times 2 is 4, sorry. Times 2 is 8, times 2 is 16. 16 times 3 to the 1st is 48, and that's my LCM. You can see the difference between the LCM and the GCF. The GCF is smaller because you have to have everything be in both boxes. LCM, it can be in either box. Let's do another one. Let's do 18 and 27. 18, I'm going to start with the prime factorization, 9 times 2, 3 times 3 times 2. I've got all prime numbers. I'm ready to do my check. 2 times 3 is 6. 6 times 3 is 18. I'm good to go. I'm going to write it smallest base to biggest base and put the 3 in exponential form and box him up. The 27, 9 times 3, 3 times 3 times 3. I'm ready to check it. 3 times 3 is 9, 9 times 3 is 27. Looks good. Write him in exponential form and box him up. And I like having my boxes right next to each other, like they are here, and like they are here, because it makes them easy to see side by side, to compare. Now I'm ready to do my T-chart. GCF and LCM. GCF, I'm looking at bases that occur in both my boxes. The only thing in common is a 3 base. That's all I write down. Now for the exponent, I go back and I look inside my boxes and I see a 3 squared and I see a 3 cubed. For GCF, we're writing the smallest exponent. That would be 3 squared. And that would make our GCF 9. For the LCM, I go back to my boxes and now I'm going to write down every single base I see. The 3 I see in both boxes, but I only write them down as a base once. Now I'm going to go put my exponents, and now instead of taking the smallest, I'm going to take the biggest exponent I see. 2, the only exponent I see, is the ghostly 1. That's 2 to the first power. 3 is to the second power here, and to the third, I'm taking the bigger one. Now I'm going to multiply it out. 2 times 3 cubed, 3 times 3 is 9, times 3 is 27, 2 times 27, and my LCM is 54, compared to my GCF of 9. You can see that the LCMs are going to be bigger. I'm going to leave number 3 for you to try. I'm going to do number 4 quickly, and then we're going to get into some that have variables in them. So let's start with our prime factorization. 4 times 5, or maybe you start with 2 times 10. 2 times 2 times 5. I'm going to prove it. 2 times 5 is 10. Doubled is 20. Yep. And I'm going to write it exponential form, and I'm going to box it. Next one, 45. 9 times 5. 3 times 3 times 5. And I'm going to prove it. 3 times 5 is 15. Times 3 is 45. Write it and box it. Last one, 50. 50 is 10 times 5, which is 5 times 2 times 5. I'm going to prove it. 5 times 2 is 10, times 5 is 50. I got it. Write it in exponential form and box it up. This is all from section 4.1, the prime factorization. It's the most important part of this, because if you get your prime factorization incorrect, your GCF and your LCM are going to be incorrect as well. Let's do the GCF and the LCM. Look at your 3 boxes. For the GCF, they've got to have it in every single box. I see a 2 here, no 2 there. I can't write them down. I see a 5 here, a 5 here, a 5 here. That's good. I'm looking at this 3 over here, but it doesn't matter. I don't see a 3 in my first box. So for the GCF, I can't write anything down but the base of 5. Now I've got to go back and put an exponent on it. This is 5 to the first power. This is 5 to the first power. This is 5 squared. 1 is lower than 2. My GCF is just 5. LCM is going to look different. I see a 2 and a 5, and over here I see a 3. Every base I see to the highest exponent. 2 is squared here. He isn't even here. Here's to the first power, 2 squared. 5's to the first, but over here he's squared. I'm taking the 2. And 3, the only place he appears, he's squared. So now I need to go figure this out. 2 squared is 4, 5 squared is 25, 3 squared is 9. 4 times 25 is 100, 100 times 9, 900 is your LCM. Ready to try one? It's got some variables? I hope so. Okay, let's get to number 5. 12, GH. So this is exactly like writing prime factorizations in 4.1. The variables are the easiest part. They just come down in your prime factorization box just like they are in the problem. 12, 4 times 3, GH. 4, 2 times 2 times 3, GH. I'm going to prove my numbers. 3 times 2 is 6, doubled is 12. Yipper dupper. Now I'm ready to write it in prime factorization. 2 squared times 3 times G times H. Box it up. 18, G squared H. 9 times 2, G squared H. Make your dot a little higher so that it doesn't look like 9.2 like mine did. 9's not prime, I can't stop. 3 times 3 times 2, G squared H. 2 times 3 is 6, times 3 is 18. I can get back to the number I need to. I'm going to write the smallest base first. 2 is going to come before 3 because 2 is smaller than 3. 3 written out twice is 3 squared. I want exponential form, and I'm ready to box it up. GCF and LCM, we need a T-chart. Now I'm going to the GCF. I need to see the bases in both boxes. I see a 2, I see a 2. Write them down. I see a 3, I see a 3. I see a G, I see a G. I see an H, I see an H. All of my bases are in both boxes. Great. Now I need to put an exponent on it. This is 2 squared. This is 2 to the first. 1 is lower than 2. This is 3 to the first. 3 squared. 1 is lower than 2. This is G to the first. This is G squared. 1 is lower than 2. And H is only to the first power. So that's the exponent I'm going to put on it. Okay, now we're ready to finish this side up with the LCM. Oh wait, the GCF. We need to do one more step. We need to multiply the 2 and the 3 together. So 6GH is our GCF. And again, you don't have to write these to the first power. If you want to, that's fine, but you don't have to. LCM would go back to our boxes. Everything starts from these boxes. They are très importante. So I write down every base I see. Again, I see a 2, a 3, a G, and an H. And now I go back and I write the biggest exponent I see. So 2 is squared here, only to the first here. 3 is squared. G is squared, and H is still to the first power because that's the highest and only exponent he has. That becomes 4. That becomes 9 GH. 36 GH is your LCM. I'm going to do one more. And then I'm wanting you to do a few of these on your own and then come to me with your questions. Let me erase this little dot, driving me crazy. Okie dokie. We're going to start with the prime factorization. 30. You can start 10 times 3 or 6 times 5. 6. 3 times 2 times 5. I'm going to prove it back. 5 times 2 is 10, times 3 is 30. We're good to go. I'm going to write it in order from smallest to largest base, and don't forget your variables. They are part of your box. 50. 25 times 2, 5 times 5 times 2. I can prove it back. 2 times 5 is 10, times 5 is 50. Smallest base, largest base. Don't forget the variables. It's so easy to forget them. All right, T-chart. GCF, LCM. Look at your bases. For the GCF, they've got to be in both boxes. I see a 2 and a 5 and a D and an E. The 3 is only in one and the F is only in one. I'm going back to pick up my variables. 2. First power, first power. Guess it's to the first power. 5, first power, second power. Take the lowest for the GCF. D is squared and cubed. 2 is lower than 3. and E is to the first and to the second. Now that I've done that, I'm ready to put my numbers back together by multiplying them together. 10 D squared E is the GCF. Last one, LCM. Now I'm going to go back and I'm going to write every base down. I don't care whether it's in just one box or not. 2 times 3 times 5. D, E, F. And we need the biggest exponents we see. 2 to the first. Guess that's what he gets. 3 to the first. 5 squared. D. Cubed and squared. 3 is bigger than 2. E is squared. And F is to the first. Our numbers look like this. 2 times 3 times 25. That's 5 squared. D cubed. E squared. F to the first. Let's figure out what this piece is. 25 times 3 is 75. Doubled, 150. D cubed, E squared, F. There, my friends, is your LCM. So hopefully this has helped you figure out. And we will work on this more in class, but please do the rest of the problems on your own and come to me with your sheet and we can check them together. Thanks, and those of you that are sick, come back soon.